Hi everyone, we're looking to solve for the perimeter of various shapes. We're going to use the Pythagorean Theorem in this case and in many cases. So first thing we want to do is kind of investigate where we can figure out where the missing side lengths or what the missing side lengths would be. As you can see, if you're solving for the perimeter of this shape, you want to know the lengths of each side. So here you're given one length, right? This is 34, so we have this, right? And then this length from B to C, we don't have it, but we know that this is a rectangle, and the side, opposite sides have the same measurement, so it has to be 12 from B to C. So we're add 12 to that, so that's done. Then we go here and we're like, okay, so C to D is 29. That's given to us, so that's great. Plus 29. And in fact, if you take this 5 here, take it away from 34, subtract from 34, you get 29. So that makes sense that this side is also 29, but we don't need this length. But we do need D to A. And D to A is what we're missing. So we know that this side length is the hypotenuse of this right triangle that you could see right here. And we know that these two are the legs of the right triangle right here, 5 and 12. So what we are missing is the hypotenuse of the right triangle. And with that, we solve it using the Pythagorean Theorem, and which is our length C, right? And so this is equal to C, the hypotenuse of the right triangle, which is equal to the square root of 5 squared plus 12 squared. And that's our Pythagorean Theorem working for us to figure out the hypotenuse. And that's going to give you 25 plus 144. And that's going to give you square root of 169, which is 13. It comes out to be a nice round 13 right there. So we're going to go ahead and replace this question mark with the number 13, which we solved for. And so that's going to be 13, and that's the hypotenuse of this side. So now we have all of our sides. And when we add all these up, right, you're going to get 88. And this didn't give us any measurements, so whatever measurements, if it's inches, feet, square, whatever it is, you can write that down. Okay, so that's how you would solve for any kind of measurements that is missing. If you can use the Pythagorean Theorem, or you could use any missing side lengths that you have clues for, you do that. All right. Let's go ahead and look at the next question here. We got this figure, and again, we have to investigate. We want to find the perimeter once again. So we have 5 here, 5 plus 10, right? Plus 10, plus 15, so that's all given to us. Plus, here comes the question mark again, right? Let's write the rest of them. Question mark here, plus, or you could just write C if you know what you're doing here, but 7, right? And every time I find, like I'm actually putting one in my equation, I put a circle around it, or you could cross it out so that you won't like double up or forget to put one in. It's always a good idea to mark it somehow that you did write the side lengths in your equation here. 6 is my next one. Okay, and so I'm good here. So I need my question mark sign. Okay, so once we're here, okay, so this is going to be a little tricky, and we're going to have to figure out a couple things. One thing is, since you know that this probably is going to be, you're going to be able to create a right triangle if you put a straight line here, right? But what are the measurements of the legs? We don't have either side. either of the measurements. So what we're going to have to do is figure this piece, this leg out, and this one. And how you would do that is you're going to figure it out by looking at some clues. As I mentioned before, sometimes you will see clues. And one of the clues is that to figure out what this leg is, let's call this leg A, okay? The way you figure out what A is you look at what's parallel to Hayes over here, right? This length from here to here. Well, how do I figure out this length? I know the entire length from here to here is 10, and I know that this piece is 6, right? So what I do is take 10 or 6 and subtract it from 10. I get 4. So A is equal to 4. That's how I get that, because I'm able to take from here to here, because this is also 6, right? And this whole piece is 10. So just take, subtract that from that and you get this piece. Okay, so this is going to equal 4. And then for me to figure out what A or B is, which is my other leg, this is going to be a little trickier actually. So B is going to equal this piece, this entire piece from here to here is 15, right? That's what 15 is. And I'm going to subtract that from, or by, so from here to here is 7, right? And then from here to here, this piece, this is 5, right? Because this is 5 here, and this is 5. So it's a little bit like you have to put pieces of the puzzle together. So 7 plus 5 is what you need to kind of look at. This entire piece from here to here, you're going to take this piece, 7 plus 5, this entire piece is 12, right? 7 plus 5 is 12. And you're going to take and subtract 12 from this piece in order to get the B here. So 7 plus 12, or 5, sorry, which was 12, subtract it from 15, that's going to give you 3. So B is equal to 3. So again, I took some time and kind of investigated what I was looking for, and saw that I could put these pieces together. But with other shapes, you have to kind of think through it a little bit and say, okay, if I have an entire piece and I have a part of that, if I take that part from the entire piece away, I'll be left with what I need, and which is this leg. So now we're going to take the 4 that we have, which is A, and 3 that we have, which is B. We use the Pythagorean theorem to solve for our question mark side, which is C here. So that's going to give us C is equal to the square root of 4, which is here, 4 squared, which is our one leg, right? Plus 3 squared, which is our other leg. And C is equal to 16 plus 9. And C will equal to square root of 25, which is equal to 5. Now, that is going to give me 5 right here. So I'm not done yet. I'll replace the question mark with 5 here. I'm going to erase that, put a 5, right? And then I get to add all this up. When you're adding, you could either kind of do, do it in a calculator, or maybe regroup it. So go 5 plus 10, these two, and then cross them out. All right, 15. 15 plus this 15 is 30. See that? 30 plus 5 is 35. And then keep adding as you move along, right? Because what you don't want to do is mess up on this last part. 35 plus 7 plus 6. I just put in the calculator and I got 48. So be very careful because you don't want to come all this far and then get here and then mess up. So you can kind of regroup your numbers here and you'll get 48. And then this is in inches, right? Because all of these were in inches. So 48 inches is the perimeter of this figure. So as you can see, each figure is done a little bit differently, and because they're giving you different questions and different clues as to what to look for. So be careful when you're solving these. Make sure that you are carefully looking at the clues that you're given and the other measurements that you have or you're given. Okay, I want you guys to now go ahead and try this one out on your own. If you finish it, go ahead and try the next one out and see what you get. You want to find the perimeter for these, and we'll come back and see the results for this. So we'll call this one question number 4 because we just did 1 and 2, right? This is number 4. And this is question number 5. Okay, go ahead and solve both of them and we'll come back with the answers. Okay, so let's go ahead and see how I got 10 for the question mark. So A, which would be the base of this right triangle, right? If we're looking at this as a right triangle, A would be one of the bases, and we got that from subtracting this piece right here from here to here, which is 8, from the entire piece on the bottom, which is 16. So 16 minus 8 is 8, so we got A. A is equal to 8, right? And then over here, B we got from subtracting 13 from this 7 here. So 13 minus 7 is B. And we got that, and which we got 6 right there, right? So these are how we got the legs. And from there, we use the Pythagorean Theorem, of course, to solve for the hypotenuse, and we got 10. So square root it, square it, add them, square root them, and we get 10. And we substitute 10 for the missing side length of the perimeter of this figure. And we get 54 centimeters as the final answer. All right, if you guys were able to follow that, let's go ahead and look at this last question here that we have. This is another composite figure where we have all these side lengths. This is missing this side length. Of course, I'm hoping that you guys can see that. This is a big rectangle here, so this side and this side are the same, right? So this is also going to be 5 centimeters. So go ahead one more time and line all this up. But this time, be careful. We got 1 centimeter on this side, 2 centimeters on this side, and the entire 8 centimeters on this side. So if you're trying to figure out this leg, right, you have to be careful with that piece, okay, what you have to add and subtract. So I'll let you go ahead and take a look and try to solve for the perimeter of this figure as well. We'll be right back. Okay, so we went ahead and again added each of the sides up very carefully. When you do that, for example, when you're going through the motions of adding, you could either circle them, like you're going like 2, put the 2 there, circle this, 5, put the 5 in the equation and circle it, 8, put the 8 and 5 again. So I would do that because when you have a lot of sides, you might forget to not put one in or skip one or so on, or double right, like put them in twice. So then 5 here, and we can see that this is 5, this measurement is 5, that one leg was given to us. We didn't have this 5, the side A, which we're going to call. And of course we didn't have the C, and we solved it later and got 7.1, but let's see how that worked. So we know that this side length is 5, which was B, right? So that was helpful, and we could figure that out. Okay, so over here, this was B. I'm going to highlight it for ourselves here a little bit, help us out. So this is B, we got that, great, there. And what we need to figure out what A is. Okay, to see what A is, you would look at this base here. This entire base is 8, right? So this base here is 8 right here. And then these two side lengths here need to get subtracted from the total. So this piece and this piece is 1 and 2, which makes 3, which is 1 plus 2, which is 3. That's what we have here, right? And we're going to subtract it from 8, which is this base. And so we get 5. So 3, right? 8 minus 3 is 5. So that's how we get this 5 for the other leg. So both legs come out to be 5, which is fine. We can do that. So we'll go ahead and start using our Pythagorean theorem, 5 squared plus 5 squared. Again, I went ahead and I used the different colors so you know this is A and this is B, and we're squaring it. Get square root of 50, and that rounds to it. It didn't come out to be a nice perfect number, 7.1. So we put 7.1 instead of the C here. That was missing in our equation. And our final answer came out to be 33.1 centimeters. Okay? So hopefully you kind of got a good idea of what and how to solve composite figures and use the Pythagorean theorem as well.